Assalamualaikum and good day everyone. Today we will learn on chapter 5, net annual premium. So what is premium? In the policy of the insured or policyholder agreed to make certain payment to the company. These payments are usually referred to as gross premium. Insurance company, policyholder or insured so insurance company pay benefit to policyholder and the policyholder or the insured have to pay premium. So we call the payment from the policyholder to the insurance company as gross premium. In consideration of the premiums paid to the company by insured, the company in turn agrees to pay a stipulated sum of money. So this is benefit, or we call it as face amount of insurance if certain events occur. So if life insurance, so the event occur would be death. The person to whom the face amount of insurance is to be paid is called the beneficiary. And the policy date or date of issue is the date upon which the insurance contract is made, and the successive years after this date are called policy years. So from the policy issued until the successive years before the event occurred. So we call it as policy years. Most life insurance companies charge gross premium, which are determined by the age of the insured or policyholder attained. So the gross premium are determined based on the age or the current age. So net premium is equal to total present value of policy benefit under the following assumption. So the benefit under the policy will be paid at the end of the policy years. The death among the policyholder will occur at exactly the rate given by the mortality table. So the death is determined using the rate given by the mortality table. So the gross premium is equal to net premium plus loading. So what is loading? So loading is the expenses or the contingencies that the insurance company have to bear. Generally, net annual premium is denoted as pi. So P with the bar is for premium for continuous. P without the bar is for the discrete case. So this is the function, the L with the premium, PV of loss as net annual premium as a function of time of death, which is the benefit, the present value of amount payable minus present value of amount collected. So there are two conditions for this case. If the expected value of premium equal to negative, so meaning that the company is not lost. But if the expected value of the premium is equal to positive, then the company lost, because this is the function for present value of loss. So the benefit, the RM1 benefit, so for fully continuous is VT minus NAP times the accumulated value until T years. So this is referring to the benefit minus this is amount of collected or the net premium. So this is for continuous case. So T referring to time of death or when it's failure. So for this is for discrete case. For discrete case, it paid at the end of the year. So T become K plus 1. And we use annuity due since we start pay the premium at age X or T equal to 0. So we will go to timeline to see it more clearly. So the first one, this is for continuous case. And this is for discrete case. So this is the premium paid by the policyholder or the insured until X plus K, when the death happened between X plus K and X plus K plus 1. Once the death happened, the benefit will be paid here for continuous case. So that's why the N is equal to T until T years. The accumulated value until T years. However, for discrete case, the benefit is paid at the end of the year. So when the death happened here between X plus K and X plus K plus 1, so the benefit will be paid here at the end of the year. That's why the N years become K plus 1. So the accumulated value is K plus 1. Starting from T equal to 0, that's why we use annuity due. So let's try example 1. An individual aged 30, so X is equal to 30, is charged premium, so this is for premium, the pi for premium, annually for a 10,000 whole life insurance, so this is benefit. This is for whole life case, with benefit payable at the end of the year of death. So meaning this is for discrete case. Calculate the expected value of this loss function when the premium is equal to 72 and 50. So let's try one by one. First, we draw the timeline. So the premium is paid starting from age 30 until the death happened. So let's say death happened between 30 plus K to 30 plus K plus 1. Since it is discrete, it pays at the end of the year, the benefit. And K can be 0, 1, 2, 3, and so forth. And then we use this formula loss function. So this is for the benefit and minus the premium. Then the expected value for this, we can use, this is actually benefit is for the insurance, and this is premium using the annuity. So the expected value of the present value, it become annuity. The expected value of the discounted interest become the insurance. So this is for discrete case. So since we are not covering discrete case for insurance, so I would like to introduce you the insurance for the discrete. So this is for whole life insurance. AX, so A30 is equal to MX over DX. So remember, for annuity, we use NX over DX. So for insurance, we use MX over DX. So we refer the same table, ILT, the illustrative life table, at I equal to 6%. So we substitute the commutation function here for both insurance and annuity. So since annuity due, we use NX. For annuity immediate, we have to use NX plus 1. So you have to refer back to chapter 4. And then we substitute the values that we found in the table. So M30 is 165.3711, and this is for D30, and this is for N30, and this is D30. So this is net annual premium, NAP. So we have two conditions, whether NAP equal to 72 or 50. So we simplify this equation. Now we want to substitute for the first case, where the net annual premium is equal to 72 inside here. And we got negative 116.84. Then we substitute net annual premium equal to 50 into the equation, and we got 231.994. So the expected loss function, if it is negative, then it means that the company gains profit for this case. Gains profit. And the second one, when we charge the premium equal to 50, the company will lose. So the company have to determine the premium between this 72 and 50. So as I recall again, this is the expected value of present value. So we will get annuity. For the expected value of VT, we will get insurance. And the insurance for whole life, MX over DX. And for the annuity due, NX over DX. So we will look at more later. So for the expected value of loss function, this is we call as equivalent principle. Where the expected value of loss function is equal to 0. So we get this formula for the net annual premium. This is for the benefit. Insurance divided with the annuity to get the net annual premium. So the insurance and the annuity, it could be referring to the ILT, the illustrative life table for the discrete case, or it can be the Morse law or constant force for TPX and MUX plus T, according to both case. So for discrete life insurance, for the commutation function, first, this is for whole life insurance. For whole life insurance, the notation is AX without the bar. AX with the bar is for the continuous one. So the commutation function is MX over DX. So we can refer to the table. So X is the current age. And then second one, for the term life insurance, discrete case, this is how we write the notation. So the commutation function is MX minus MX plus N over DX. And the third one is pure endowment. So this is the notation for pure endowment. So pure endowment is about surviving. So surviving is referring to dx. So dx plus n over dx. And the fourth one is endowment. So endowment is actually the summation of term and pure endowment. So the summation of this two. So mx minus mx plus n plus dx plus n over dx. So we combine these two and we get this one. And the last one for deferred insurance. So first one is for whole life deferred insurance for n years. So mx plus n over dx. So the numerator is x plus n and the denominator still use the current age, same as this whole life. Only the difference is the numerator. For the second one is for deferred insurance for m years for the temporary one, for n years, only for n years. So mx plus m minus mx plus m plus n divided by dx. So the dx is surviving. So all the cases for insurance and for the annuity, the denominator is dx. Okay, so for discrete annuity, we already covered in chapter 4. So let Px denote the annual premium for an ordinary life policy issued at age X. Since the PV of this premium is by definition equal to the NSP for the benefit provided by the policy. So this is for the premium part times the annuity, and this is for insurance. So actually premium Px is equal to Ax over annuity due. So this is for insurance and this is for annuity due. And this is for whole life case. When we use commutation function, actually Px is equal to Mx over Nx. So now we look at this. So Ax, when we use commutation function, is equal to Mx over dx. Meanwhile, annuity due is equal to Nx over dx. Therefore, Ax over annuity due is equal to Mx over Nx because we cancel out the Tx. That's why we got Px is equal to Mx over Nx. This is for one's payment of premium because we have one at the back. So for this case, for NPX, where the net level premium for a limited payment life policy with a premium payment period of n years. So the premium is temporary, but for the whole life insurance. Same as the equation for the previous one. So still we use NPX time the annuity equal to Ax. However, we have to use temporary annuity due for n years. So NPX is equal to Ax for whole life insurance divided by the temporary annuity due for n years. So Ax is Mx over dx divided by, so the annuity due for the temporary is Nx minus Nx plus n over dx. So we cancel out, and the last one we get Npx is equal to Mx over Nx minus Nx plus n.